Hi, this is John, and today we're gonna talk about some common emitter and Miller effect in these common emitter amplifier. So for explanation, we're gonna assume that there's a common emitter like this that has a load impedance between input and output like this. Yep, as you can see, we have a and as we all know that the current that get into the amplifier is zero, right? So we can just consider about the current that flows to a impedance, the load impedance in here, like this. So we can get some relation equations of the amplifier. So for the first, we can use Ohm's law with those load impedance, which is the VI equals R over V. We can express this as a impedance over V. Uh, I mean, yeah, impedance over V. And also, the amplifier, the ratio between the input voltage and output voltage is minus AV in this circuit. So we can get an equation like this with the input voltage and output voltage. So with these equations we can use input voltage and output voltage for Ohm's law like this. So input minus output voltage divided by impedance. This is a current that flows to the load impedance, right? So in here, the output voltage is a minus AV input voltage. So we can change this equation with the V input times 1 plus AV over impedance, right? So So for the input impedance in here, input impedance of these amplifier, we can make a equation like this. It's also a Ohm's law, right? So input impedance equals input voltage over input current. So before before this, we already get a input current equation, so we can put this in these. So we can get input impedance is load impedance over 1 plus AV, right? And for impedance, we all know that impedance Z is J omega C 1 over J omega C like this, and we can change J omega as C S, so we can express Z impedance equals 1 over SC. So when we use this with those input impedance, we can get input impedance equals 1 over SCM, which is the capacitance affected by a Miller effect, and the Cm is C times 1 plus AV. So this is a result of the Miller effect, which is when we saw the input, when we saw the inside capacitance from the input impedance. So when we saw the input impedance inside impedance from the input impedance, and we can see that the inside capacitance is bigger than the initial capacitance C. So this is a Miller effect. So the Miller effect, these Miller effect have some problems, because when we draw a frequency and the free input and free output plot like this, and so in here, here's a lower frequency, here's a low frequency domain, and here's a high frequency domain. So as we learned from the, I forgot the name, but Heroiron 1, I forgot the English name, but Heroiron 1, or I think it's 2, but this will be a high pass filter, and this will be a low pass filter, right? Am I doing right? I think. Yeah, here will be a high pass filter, and here will be a low pass filter. So the low frequency, so in the low pass filter, the low frequency domain will pass and high frequency domain will filter. And in the low pass filter, we can express the frequency f is 1 over 2 pi RC, and conversely, in the high pass filter, the high frequency domain will pass and low frequency domain will filter. So we can express the frequency in high pass filter with the RC over 2 pi. So when in this situation, we can let's think about the Miller effect. What's the Miller effect that I said before? Miller effect is the capacitance gets bigger when we saw the inside capacitance from the input impedance, right? So it means in these graph, in this plot, the capacitance will be bigger by the Miller effect. So when the capacitance will bigger in the lower pass filter, the 2 pi RC part will be bigger than before, so the frequency will get lower. So it gets a little more left from than before. And in high frequency, I mean the high pass filter, when capacitance gets bigger, the frequency will get bigger also. So this graph will be moved more right than before. And then the distance between those two pass filters graph will be a bandwidth, and the bandwidth gets smaller than before by the Miller effect. So this is the result for affected by the Miller effect. And so in common emitter amplifier like this, we can get a limitation of the bandwidth because of the Miller effect.